Good evening, everyone. Okay, today we will actually learn about testing for aldehydes and ketone. Okay, we have learned about aldehyde and ketone. Okay, carbonyl compounds. Okay, they are separated or divided into aldehyde and ketones. They have this C double bond O, and then you have R, and this one is H. That's for aldehyde. And then if you have ketone, ketone is going to be R, C double bond O, and another R. So take note of that. Now, testing, okay, when it comes to testing, so we will use some chemicals, okay, available, and then we are going to actually test, okay, for aldehyde and ketone. So the first test that we are going to actually do is going to be testing with 2,4-DNPH, okay, DNPH. What is DNPH? The full name, okay, is going to be 2,4-dinitro, okay, dinitrophenylhydrazine. Okay, so for now, okay, you do not need to know the full name. Okay, later we will learn about the full name. I will actually give you time. Okay, but for now, I just want you to remember 2,4-DNPH. Okay, is going to be used to identify whether aldehyde or ketone present. Okay, it means it's a test for carbonyl compound. So they can actually test for any compound that actually has a carbonyl group or going to be ketone. So it will give you a positive result. Now the positive result is, okay, a deep orange precipitate. A deep orange precipitate. So you can see here in the diagram, the deep orange precipitate is given in the diagram over there. So if you have aldehyde and ketone, you are going to get a deep orange precipitate. Now this precipitate, okay, you can change it into crystals, okay, it will give you the deep orange crystal. And we can actually identify this crystal, okay, belongs to the product, okay, this is the product that we are going to get. It belongs to certain this product by identifying the melting point. This melting point can be found experimentally. But what I want you to know now is, okay, I want you to know that 2,4-DNPH is going to be used to identify carbonyl compound. And then the positive test is going to be a deep orange precipitate. Now, before we go on with the equation, I want you to have a look at 2,4-DNPH, the structure. Okay, the structure is given over here. This is the structure. You will have a ring, a benzene ring, we call it. Okay, and then it is actually connected. Okay, this NO2. So basically, this one is the same, NO2, and this one is also NO2. Okay, so you are going to have, okay, a molecule that has two NO2s, and then at this position, if you look at this as number one, let's say if I put this as carbon number one, carbon number two, carbon number three, at the fourth position, okay, at the fourth position, you are going to have N, and this N is connected to H2 and connected to H. So if I actually try to redraw this molecule, okay, I will actually have something like this. Okay, this is going to be carbon number one. So you have NO2, and then you will have another NO2 here. 1, 2, 3, 4. So at here, you have nitrogen. This nitrogen is connected. Okay, if you look over here, it's connected to what? Okay, it's connected to NH2. Okay, and connected to hydrogen. So if I just draw it again, okay, this one is going to be connected to NH2, and then this is going to be hydrogen. So this is going to be 2,4-DNPH. You need to know about this. Okay, if I go again to the previous slide. So what is going to happen? So if you have, okay, if you have a compound which is going to be a carbonyl compound, let it be aldehyde or ketone. Okay, when you have this compound, okay, what is going to happen? There is going to be a condensation reaction is going to happen. What is condensation reaction? Water will be released. So the oxygen, okay, from the carbonyl compound, okay, is going to actually react with the H2 from the NH2 over here, okay, and then they will actually give you H2O, and then left with this molecule. You can see the molecule, they rewrote the molecule until N connected to another N, N connected to another N, and now the double bond will be connected directly to the nitrogen. Okay, so if I try to replicate this equation over here, so let's say now if I want to actually react, okay, with a molecule, let's say I have a carbonyl compound, a ketone, a propanone exactly. Okay, let's say if I have CH3 and I have CH3, what is going to happen over here is, okay, you are going to have, okay, this hydrogen, these two hydrogen from here will actually go out with this oxygen over here to give you water. And then what's going to happen next is you just need to redraw the entire thing over here. So let's say I don't want to redraw, I'm just going to copy and paste, okay? Copy, then I'll paste it over here, okay? If I have this, okay? Now, if I have this, okay, what's going to happen is I'm going to put it here, okay? You see this part. So what's going to happen next is this nitrogen is going to join with this carbon, double bond carbon, and then you have CH3, and then you have CH3. So this one is going to be the product that you are going to get. So what is this compound? Okay, this compound is going to be known as 2,4-dinitrophenylhydrazone. Okay, so something to do with 2,4-D and pH, but it's a salt. Okay, it's a salt, hydrazone. Okay, so this is the one, okay, which will give you a deep orange precipitate. So this one is going to be a hydrazone, okay, hydrazone, and this is the one responsible to give you a deep orange precipitate. And if you crystalline this, it means you do crystallization, it will give you a deep orange crystals as well. Okay, do you have any question up to here? Guys?
No, sir.
So this is, yeah, this is going to be testing for 2,4-D and pH. It is applicable for both aldehyde or ketone. So let's say if it is aldehyde, if you put this, cancel this as H, this is aldehyde, ethanol. So the same thing, you just cancel this and put the H, that's it. Okay, so this positive results is applicable for both aldehyde and ketone. So it's a test, just a general test to identify whether there is a carbonyl group, or to identify whether there is a carbonyl group or aldehyde or ketone present. Okay, so this one is just a general test. So the next test that we are going to look at is going to be TOLLEN'S region. Okay, now it's going to be more specific. Okay, if you have 2,4-D and pH to test both, but now TOLLEN, and we have also another one, FEHLING. Okay, I'll just teach both of them together, TOLLEN and FEHLING solution. Now TOLLEN'S region and FEHLING solution, they work based on the ability of the compound to be oxidized. Okay, they will actually, so to be oxidized, basically they are oxidizing agents, and we have learned in chemistry, okay, there are two strong oxidizing agents. Okay, can you actually give me the example of the two strong oxidizing agents, Kenneth? Example of two oxidizing agents.
Acidified potassium dichromate.
Okay, good. Acidified potassium dichromate. Yes, so basically it's acidified potassium. Yes, good. Okay, acidified potassium dichromate or potassium dichromate. Okay, this one must be acidified. Now take note, these two are strong oxidizing agent. And we do have some other oxidizing agent. In this case, now I want you to learn TOLLEN'S region and FEHLING solution, they are oxidizing agent, but they are very mild oxidizing agents. So generally, we don't use them to oxidize alcohol. We don't use them to oxidize aldehyde to become carboxylic acid. So we only use these two. But now, okay, this mild oxidizing agent, okay, what they will actually do, they still capable to change aldehyde. Okay, they are still capable to change aldehyde to become carboxylic acid. Okay, they are capable to change aldehyde to become carboxylic acid. FEHLING'S solution also still capable to change aldehyde to carboxylic acid. Now, take note ketone. Okay, ketone, do they get oxidized? They do not get oxidized. Okay, they don't get oxidized. So ketone do not get oxidized. So for both reaction, okay, involving FEHLING'S solution and TOLLEN'S region, ketone will give you a negative result. Okay, the positive result, okay, you can see from the diagram over here, TOLLEN'S region, okay, will give you a something to do with, you are going to get the test tube, okay, will become like some kind of mirror, okay. If you stand in front of this test tube, it means the mirror image, okay, will be formed, okay. If you have a very nice looking face over here, you can see your face over there. So that's going to be a mirror image, okay, will be formed. So that's something like you can see a mirror being formed inside the test tube, okay. So this is going to be the positive results, okay. The positive result for TOLLEN'S region, okay, is going to, you will have something like a mirror, mirror being formed inside the test tube. So what is TOLLEN'S region actually? Okay, TOLLEN'S region, okay, is going to be silver nitrate solution, okay, in excess ammonia, okay, silver nitrate in excess ammonia. And the full name, okay, you can see the full name over there, ammoniacal silver nitrate solution. But I just want you to remember, okay, it's silver nitrate with ammonia, okay, with ammonia. So what's going to happen is this silver ion, okay, is a very mild oxidizing agent. So this is silver ion. Now this silver ion, okay, if they can actually oxidize aldehyde, they get reduced. Okay, if you look at the oxidation number, it's +1. So let's say if I put aldehyde there, okay, what's going to happen is the aldehyde, okay, can be changed into carboxylic acid. Okay, the aldehyde can be changed into carboxylic acid. So what's going to happen over here is basically the silver ion, they will get, okay, if this one is oxidized, okay, they will get reduced. So it means they are going to get to become Ag. So it means Ag, the oxidation number is 0. You can see from +1 to become 0. Okay. So these silver atoms or the metal is the one that is responsible to give you the silver effect. Okay. So here they say that, okay, if you have, okay, silver ion, they behave as a mild oxidizing agent. So what's going to happen next? A carboxylate ion is formed under alkaline solution. Okay, I don't want you to actually focus so much whether what kind of ion and so on. Basically, what's going to happen over here is aldehyde will change into carboxylic acid. Now, carboxylic acid is acid. So if you react with, because it's an alkaline solution, ammonia solution, acid will react with alkaline solution to give you salt. Okay, like acid plus base to give you salt and water. So that salt is known as carboxylate ion. So it's not going to remain as carboxylic acid. So that's why they actually put it as carboxylate ion. Don't worry so much about it. I will actually discuss about this in future lessons. But what I want you to look at is going to be how the silver ions, okay, the silver ions over here, they change into silver atoms or silver metal. So that is the one that is going to be responsible to give you the mirror effect. Okay, so the TOLLEN region, okay, if you test with ketone, they do not get oxidized. So what happens is, if you have TOLLEN'S region over here, TOLLEN is silver nitrate, is colorless, ammonia is also colorless. So it's going to be still going to remain colorless. So it's going to be a negative result. But if you have aldehyde, okay, the result is going to be positive, which is going to give you the silver mirror effect. So it's a test to identify aldehyde. So if you have a carbonyl compound, so if you have, for example, propanone, and you have propanal, and you want to identify which one is propanal, okay, you use TOLLEN'S region. Is that clear?
Yes.
Okay, we go for the next test. Okay, the next test just now was TOLLEN. If TOLLEN, okay, because TOLLEN is actually related to silver nitrate in ammonia. Okay, so now, okay, it's going to be phthalate. Okay, phthalate, okay, solution is going to be containing copper 2 ion. Okay, copper 2 ion, and it's also alkaline solution. Take note, if it is alkaline solution, you are going to get a carboxylate ion. So basically, the aldehyde will change into carboxylic acid. The carboxylic acid will react with the alkaline solution. They will give you the salt. That's why you have the carboxylate ion over there. But what I want you to focus over here is, just now, okay, you do not need to warm the mixture. But now for phthalate, you need to actually warm. Okay, you need to heat. Okay, you need to heat with aldehyde. And what happens, the aldehyde, okay, they will actually change into, again, carboxylic acid. They will change into carboxylic acid. And after that, they change into carboxylate ions. Okay, but what happens over here, if you have the copper 2 ions, okay, the copper 2 ions, they will change into copper plus ion. Okay, because if this is oxidized, they get reduced. Okay, you can see that plus 2 become plus 1. Okay, it's reduction. Okay, so they change into copper plus. Copper plus, okay, copper 2 plus is blue. Okay, and then copper plus, which is going to be copper 1 oxide. Okay, they will form copper 1 oxide. That's going to be copper 1 oxide is Cu plus and 2 minus, so it will give you Cu2O. And this is going to be red or orange precipitate. Okay, so if you are using a ketone, the solution remains blue, still remains as Cu2 plus. But if you are using aldehyde, okay, when you heat up, okay, basically you need to heat up. Okay, if you heat up, so what's going to happen? They are going to change, okay, into red orange precipitate. So take note about all the positive results. Yeah. So the first positive results when we actually learn about testing is 2,4-DNPH. Don't get confused with this. This is going to be deep orange precipitate, and you can see the color, deep orange precipitate. But the second one, tollen, is going to be a silver mirror. And then the third one that we learn over here is going to be red orange precipitate. So you can see it's quite different. And this one can change into crystal. Okay, can change into crystal. So it's very much different compared to each other. Okay, do you have any question up to here? Sydney, do you have question?
No, sir.
Okay, now I want you to actually have a look at this small part that I put over here. Okay, how about carboxylic acid and ester? Okay, carboxylic acid and ester, even though they contain the C double bond O, okay, because carboxylic acid C double bond O and then COOH-R, okay, even though they have this, okay, and then ester, if it is R1, C double bond O, O, and then R2, even though they have this, take note, okay, carboxylic acid and ester, okay, if you go and test using 2,4-DNPH, do you think, will there be any positive results? Wesley, what do you think?
If with what?
If I react with 2,4-DNPH, yes, do you think carboxylic acid and ester will give you a positive result?
No.
Yeah, no. So basically, they are different compounds, even though they have this react is different. So this one will be no reaction. Okay, basically there won't be any deep orange precipitate will be formed. Okay, I hope it's clear. So I've covered with you, okay, 3 reactions, okay, 3 reactions. And these 3 reactions are very important, okay, but, okay, there is one more, okay, one more reaction that I need to cover with you guys also. Now, the last reaction that I need to cover with you guys is called triiodo, okay, it means tri means 3, then iodo contains 3 iodine, methane. Methane is supposed to be CH4. Now, if I join them together, okay, if they say triiodomethane, this is methane, methane being substituted with 3 iodine. So you are going to get CH, the remaining 3 hydrogen will be substituted by iodine. So this one is triiodomethane reaction. You can actually write it as CHI3 reaction. Okay, what is CHI3? Okay, just now 2,4-DNPH is the reactant. But okay, CHI3 is actually not reactant. Okay, they are the precipitate. Okay, they are the precipitate, CHI3. It means they are going to give you CHI3. Okay, so what is the color of CHI3? We can start from there first, okay, because you can see the color over here. What is the color over here? The color is going to crystal. Okay, yellow precipitate or crystals, and then the melting point is 119. Okay, I want you to actually really remember about the precipitate. Yellow precipitate triiodomethane reaction. If you have, okay, DNPH, that's going to be a deep orange precipitate. But if you have FEHLING'S solution, that's going to be orange precipitate. So you see, there's so many colors over here. So deep orange, a very bright orange comes for 2,4-DNPH. If it is FEHLING, it's going to be, you can just remember, rather than putting red, you can just say orange precipitate. But for triiodomethane, you are going to get yellow precipitate. It's yellow, okay, not orange. Okay, it's yellow precipitate, and you can see the color of the precipitate also here. Okay, it's more like forming like some kind of crystals and so on. Now, what is the reactant that will be used? Okay, before we go for the testing, what do they test? Okay, it's actually alkaline solution of iodine. It means this is going to be I2. Okay, and then they put alkaline. So alkaline can be sodium hydroxide, potassium hydroxide. I'll just put sodium hydroxide. And they are going to actually warm it. Okay, they are going to heat it up. Sodium hydroxide and I2. Now, it's a test, a very specific test. It's not actually like something like they will test for aldehyde. They will test for ketone. No, they are very much specific. How specific? It's a test to identify C double bond O, C double bond O, and then CH3. That has this structure will give you a positive results. It can be this aldehyde, which is ethanol. Okay. Can it be other type of aldehyde? Like for example, if I have propanol, okay, if I have propanol, CCC double bond OH. Now this one I'll ask who? Maybe Shirley. Shirley, do you think, okay, propanol will have a positive reaction with triiodomethane reaction?
No.
No. Why? They do have this CO, okay, but this part, they don't have CH3. So I want you to actually remember this, okay? Ethanol is the only aldehyde, okay? Ethanol is the only aldehyde that will give you a positive results with triiodomethane reaction, okay? Ethanol is the only aldehyde which will give you a positive reaction with triiodomethane. But you will have a lot of ketone, okay? A lot of ketone to give you similar reaction. One type of ketone, let's say if I have something like this, okay? There is CH3, there's O, fine. If let's say I change this into another ketone, let's say I have C2H5, okay? That's fine, still fine, as long as they have CH3 and O over there. Okay, but if I have something like this, C2H5, no reaction. Okay, so you must have CH3 over there. So if I erase this part so that we have more space to write. So what's going to happen over here is, okay, they mentioned that this reaction must have, okay, this group, okay. And what happens exactly, okay, that's why I said methyl ketone. Ketone must have the methyl group. Okay, they will actually form a yellow precipitate or crystal. So what actually happens over here is, if you have a R group, C double bond O and CH3. Okay, the R can be H, can be other R groups. So what happens over here is going to be when you have the I2 and then NaOH, okay, this will change them, okay, into R, C double bond O, and then this C, this H, okay, this H, all these three H will be replaced by iodine to give you Ci3. Okay, the next step, okay, is where you are going to change, okay, this one into hydrolysis. It means this one will be broken. Okay, this bond is going to be broken. So what's going to happen is going to be because of the sodium hydroxide here. Okay, the bond will be broken. So you are going to get CHI3. Okay, this part will give you CHI3. And this part, okay, because of presence of water, okay. So what's going to happen is you are going to get RC double bond O and then OH. But take note, you are using sodium hydroxide, okay. This part, they will form a salt. So they will give you a salt over there. Okay, so that's why you can see over here there is a salt and then CHI3. Now, if this equation seems to be too difficult for you guys, you can actually do it later. But I want you to remember, anything that has this structure will give you a positive results. Okay, and you are going to get a hydrolysis. Basically, first the iodine will get substituted over there. Okay, and after it gets substituted over there, there is going to be a hydrolysis reaction going to happen, and you are going to get CHI3, which is the triiodomethane. And this triiodomethane is going to be a yellow precipitate, or will form you the yellow crystal. Is that clear? Guys? I know there's so many
Yes.
things. Yeah, there's so many things. Okay, so I'll just actually do a recap only. Okay, I'll just do a recap. Anyway, this lesson I have recorded. You can actually see the lesson again. I will upload in YouTube. You can actually go through the lesson again. So anyway, there are total of 4 things that we learned today. Okay, one is going to be 2,4-DNPH. Okay, second is going to be tollen. Okay, and then third is FEHLING. Okay, FEHLING solution, TOLLEN'S region. And then the last one is triiodomethane reaction. So if you look at 2,4-DNPH, okay, the structure, you need to know the structure, okay, because it's actually a molecule. You can actually go through this again and again, no problem. Okay, I understand if you don't get it at the first time. Okay, this is going to be the molecule. Then after that, it will react with, let's say, C double bond O, R and R, for example. The H2O, okay, will be coming out. And you are going to get this molecule, a hydrazone molecule. So N with another N, double bond O, R, and R. This is C. And then this is H. And this is going to be the color. Can someone tell me what is the color, Wesley?
Deep orange.
Good. Okay, this is going to be a deep orange precipitate or crystal, can be crystallized. Now, TOLLEN'S region, okay, TOLLEN'S region, Hansen, can you tell me TOLLEN'S region is made of what and what? What are the regions?
Silver
nitrate, yeah, silver nitrate
and
in ammonia. Yeah. So what happens over here is the Ag plus is changing into Ag, so you will get the mirror effect. So this one is suitable for aldehyde only. Okay. For this one, it's both aldehyde and ketone. So for FEHLING solution, it's going to be different. It's going to be Cu2 plus. Okay, Cu2 plus again with any kind of let's say if you're using what should I say? If you're using alkaline solution, okay, alkaline solution. So basically, it's going to be Cu2 plus. It's going to change it to Cu plus. It's only for aldehyde. So you will actually have, okay, the positive results. Okay, the positive results for FEHLING is going to be the blue. Okay, the clear blue will change into orange precipitate. Okay, you can memorize that. Triiodomethane is going to be a situation where you are going to look for C double bond O. Yeah.
We cannot hear.
Cannot hear.
I cannot.
Let me see. Yeah. Cannot see. Impossible. Can you see now?
Judy is lying.
Okay. Anyway, I'm connected to two devices. I can actually see the screen. Okay. If you cannot hear, probably possible. But anyway, I'm just going to finish anyway. So you are going to get this CH3. Okay. So this is going to be, if you have any R group over there, okay, they are going to actually give you CHI3. Okay. I want you to find out about the equations that are involved. I went through the equations just now, but this one is going to be a yellow precipitate. And this yellow precipitate is going to be suitable for any carbonyl compounds that has this structure. And there is another one also, okay, related to alcohol, okay, related to alcohol, I put over here. Other than carbonyl compound, okay, you can also test using triiodomethane involving alcohol. And that alcohol, okay, must have C, okay, again, CH3, and then there must be OH, of course. They must have H over there, okay. So they must have this structure, and then maybe I'll just put the CH3 over here, and then I put over here as the R group, okay. Anything that has this alcohol, that has this CH3, H, and OH, okay, this one is supposed to be a secondary alcohol. This kind of secondary alcohol, they also give you a positive results with CHI3. So I want you to remember that also. Is that clear? This is for today's lesson. Okay, I want you to go through this lesson. Okay, you can check the video in the YouTube. I will actually upload the video in YouTube. Okay, I still have 1 more minute. If you want to ask question, you can actually ask question. Hello, guys.
Sir, you will be repeating this, right?
I will be repeating this again tomorrow. Okay, tomorrow. But again, the same. If you, rather than waiting until tomorrow, if you still want to listen for this today's lesson again, it's recorded. It's a 40 minutes lesson, so you can actually check it in the YouTube. I'm actually going to upload it immediately now.
Okay, thank you, sir.
Okay, see you guys. Bye.
Bye, sir.
Bye,
Thank
sir.
you.
Bye, sir.
Bye. See you.
Thank
Bye.
you.
Yeah.
Bye, sir.
Bye.
Bye, sir.
Bye, sir.
Bye. See you.